All right, Laker engineers, let's go ahead and try to put this idea, this new idea, the empirical rule to use. Again, we're going to continue with the idea of IQs. And remember, what that means is if we have so many IQ tests taken, we know some people are going to score maybe over here, right, really high. Some people are going to score over low, but most people are going to score somewhere in this region. So mu is the average variable in this case. For IQs, that's standardized that they standardize that the average IQ is a value of 100. Okay, so I'm going to put 100 right there. This is a generic form, so we're just putting the data specifically for an IQ analysis on this one. From the research literature, the standard deviation in an IQ test is 15. So that means sometimes people would score one standard deviation higher, and that would be on here. That's average plus standard deviation. So that'd be 115, right? An average plus two standard deviations would be 130, and then way over here, an average plus 3 standard deviations would be 145. We'll do it on the other side too. This is an average minus a standard deviation, so we're taking 15 away this time from 100, so this would be 85. And we take 30 away, so this one will be 70. And then we take 45 away, so this one would be 55. So again, how do we read the histogram at this point? Is we just sort of read it. Most people, right? That's what the high value over here is, are going to score somewhere around here. Very rare is the person that scores over 145. Very rare is the person that scores under 50. Most people are going to be here. So what I want you to do right now is just go through the questions and take a moment, pause the video, try to answer those questions, reason through, don't be afraid to get them wrong. But go ahead and pause the video right now and try to get them answered, and then we'll come back and take a look at what the answers should be and maybe how we got those answers. I mean it, pause it. Don't let those answers come up in front of you. Try to do it on your own. Okay, here are your answers. 50%, 68%, 0.15%, and 16%. So let's delve in a little bit into how we got those. It's useful to chunk up each one of these kind of pieces, kind of looks like starts like a rectangle down here, into percentages based on what we know. So let's just see what we do know. The first one, we'll start from the inside out. The first one, if we're within one standard deviation above the mean and one standard deviation below, that means 68% of our measurement should fall within that range. So this whole width from one below to one above is 68% of all the measurements. So I'm going to just cut that in half and say, well, that means this part should be 34% and this part should be 34%. That's one way to take a look at it, right? The next step in is, what are each one of these? Which percent would these be? Well, our empirical rule says then 95% of all measurements or all data are going to fall within 2 standard deviations above and 2 standard deviations below. So 95%, and that includes this 68%. So what is this? What is these? This is going to be 95 minus 68, right? 95 minus 68 is 27. So both of these together add to 27%. So I'm going to take half of that, which is 13.5. Put it there. Half of that, put 13.5 here. So if I add all these numbers up together, that comes out to this 95%. Let's figure out the rarities above and the rarities below in this case. So if I go all the way to 3 standard deviations above, or I go all the way to 3 standard deviations below the average, that's going to cover most of our data, 99.7%. So the difference between 99.7 and 95 is 4.7. So both of these areas down here have to cover 4.7% combined. So each one of them will be half of that 4.7. And if I do that, I'll put it above in this case so I can make it large enough to see, 2.35. 2.35%. And then finally, the super rarities, right? Once we go past 3 standard deviations, and once we go past 3 standard deviations below the mean, then we're talking about what's left, 0.3%. So these rarities on these sides, whoops, occupy 0.3%. Each one of those then would be half of that. So this one would be 0.15%. So once we partition the percentages based on the empirical rule, it's been partitioned now. So now the answers to most of these types of questions become pretty simple. What percentage of the population had IQ greater than 100? Well, remember, this is 100. And if it's normally distributed, we expect half to be greater than 100 and half to be below 100. Sorry about that. I keep getting interrupted by the announcements. So then the next question, what percentage of the population has an IQ between 85 and 115? Well, 85 is 1 standard deviation below. You gotta be kidding me. One more time, see if we can get through this without being interrupted. IQ between 85 and 115. So 85 is 1 standard deviation below the mean. 115 is 1 standard deviation above. 34, 34, 68% fall within that 1 standard deviation, plus or minus. The next one, what percentage of the population has an IQ greater than 145? Well, 145 is 3 standard deviations above the mean. So what's this little portion correspond to? 0.15%. So far less than 1% of the population has an IQ of that level. And then the last one, number 4, what percentage of the population has an IQ lower than 85? So we'll look up here. Here's 85. This would be the population lower than 85. And if I add those up, 13.5, 2.35, and 0.15, we'll get 16%. So that's just an introduction to how we're going to use this idea of the empirical rule for normal distributions. Let's see what you can do with the data that you're going to generate yourself.